Hi, I'm Mark Wilson, the Engineering Heretic, and today I just want to look at a thing I've been experimenting with when it comes to gears or bevel gears. Like I did a series before on cutting bevel gears. I talked about the three types of cutting. One, you can project the profile in and have it clearance. One, you can bring the profile out and have it interfere. And one, you can put the profile in the center of the teeth there and have sort of half of the best of both worlds. But with that method of the three cut method I talked about before, I was wondering, is there a way of changing the angles of the cutter in relation to the gear itself to see if I can get this gear to work in only one cut? And effectively, this particular gear here, I'm using the profile is on the inside of the teeth, the three cut metal I talked about before, and I've come up with an angle, or effectively a thing called profile shifting. Now, profile shifting is when you move the cutter in or out to increase the size of the gear. You can do it for clearance, for oil and things like that between the gears, or you can do it for a number of reasons. But in this particular case, I have profile shifted the back half of this tooth here. So it's correct here, and I have profile shifted or effectively gone deeper. In other words, I've changed the angle of the cutter as it comes down here to make, and I'll show you on the, I'll just go edit this in a separate window. Okay, we've got this in a separate window here, and let's look at my profile. I've just changed a few things here. Normally, where's my profile? Edit. This is my profile. This is what I've come up with. Effectively, my cutter will now run on this particular angle down here. This one here, of course, is 45 degrees. I've made the top of this profile here parallel, so that's 45 degrees as well. But effectively, my cutter is going to come from the very bottom of the cutter on this particular angle here, cutting through that point there and continuing. In other words, I'm going to go deeper, profile shifting the cutter as it progresses through here. Now, of course, it's going to run out of steam in the end of it because this particular the cutter is only so wide, and it will run out of depth. Obviously, you're going profile shifting deeper and deeper as you go in here. So effectively, I'm going to run out of distance before my cutter becomes unserviceable. But I'll just go out of this here and we'll take a look. I'll deactivate that sketch. We'll regenerate at the last figure. And I believe I've gone as far as I can with the length in this direction here. You'll see a little bit of a sliver left over, but effectively that is not, the cutter will wipe that out. So I can just leave that there. It's not going to affect anything. And you can see here the top of the tooth is more or less parallel on the top there. And of course, the cutter is getting deeper and deeper because I've got that parallel there with the halfway point. It doesn't change that much at all, except that the cutter is going deeper and deeper down in the groove. Let's see how that interacts with another gear of the same type. We'll get out of this one here, close the window. Now you can see this little sliver here. Kind of just ignore that. I've got the two gears in mesh, and I'll grab that one there, and you can see that I was on the inside profile. That's looking pretty good. So let's flip it over and see what this looks like on the other side there and see if we've got the clearance right. So we'll just go back into isometric. We'll just flip that around and we'll examine how this works on the back end there, because that's how it's important. So now we can see here there's a slight interference, but we're talking microns here. So, and don't forget these gears are adjustable. You can see this sliver here is going to disappear. The cutter will wipe that out. And so you see, now you can see here the depth obviously is changing because that is no longer, that's not parallel with the top of that tooth there. But you see here, that looks like it runs pretty much parallel, or the contact point runs parallel. So I believe if I change that profile, and I've got a particular angle that I need to run my cutter at to make this work. We'll just have a look and see, you see that running there. It's pretty good. We'll flip around the other way. Looking down the inside here, and that also looks pretty good. So now let's look at this model itself. I'll go back out of here. We'll go back into the model. It's the single model. Edit in a separate window. And let's look at the depth or the angle I have to run this cutter at. So the normal one through the halfway point is 45 degrees. The top of the tooth is also 45 degrees. But the angle of the cutter as it comes down through here is this one here. I'll go edit that one there because that's how I came up with the angle. This particular angle is 39.9, or basically 40 degrees. So the angle is 40 degrees, not 45. So I've changed that by 5 degrees. Going down deeper into the part, basically profile shifting as it continues through. And because, close that one there, and then I've gone as far as I can in the length before it basically runs out of steam here. You can't go any longer than that length there because my profile would, the cutter wouldn't be wide enough or deep enough to actually do it. So I believe I've come up with a particular model that will actually work in the one cut method by profile shifting on an angle down through as the cutter works its way through there. So effectively the tooth gets deeper and deeper there. But because I've maintained that parallel on the top there, it's more or less parallel on the top there. And of course, this little sliver will disappear because the cutter will wipe that out. That's the model. I'll need to give this a bit of a shot on the mill itself and have a go. But I believe that will work in the one cut method, cutting a full width profile. And I believe I've got, I think it's, what's the length of my width of my tooth? It's quite long actually. Where are we? Edit. We've got 6.5 millimeters in metric module 1. Of course, that's 2.5 millimeter depth. Okay, and we've got 6.5 millimeters in the length of that, which is reasonably long. I can't really go any longer because my cutter will run out of depth and run out of steam, so that's about as far as I can go. And that's my interpretation of a profile shifted gear that will basically give me the same qualities as the 3-cut method in only one cut, and do just as good a job. And I'm Mark Wilson, and thanks for watching.